Alright, this video, go to the file section. For this video is for STA 3032 Engineering Statistics class, and today we're going to go over creating NumPy arrays. So go to the file section of your web courses and download creating NumPy's arrays and install that into your notebooks directory. And that's for most people, it should be C program files, all the way at the bottom in Python, notebooks, and I've placed mine in intro to Python, and I've put it right there. So now, go ahead and click our Python icon down there, the Jupyter Notebook, and that'll open up the screen that looks like this. And go ahead and open up creating NumPy arrays. Okay, so NumPy is the core library for scientific computing in Python. So most of these other libraries rely on the underlying support that they get from using NumPy. So NumPy, you import it, and as you've seen in class and some other videos, there's an import statement that says NumPy as NP. So when you see NP down in the code later on, you understand that we're using NumPy libraries. This line of code right here is, you can type that in exactly as is, but that gives you IntelliSense. And I'll explain that in a little bit later, but what that does is it helps when you start typing stuff out, it'll auto-complete stuff if you hit Control Space. So go ahead and import NumPy, and this is the syntax you've seen already, creating lists in Python. So this is a standard list in Python. Now we're going to create what's called a NumPy array. So np.array, and then you pass in either a reference to an array, or to a list, which is this simple list here. So you're going to pass that into the constructor of the array class here, and that's going to create a new variable x, and that x is a NumPy array rather than a Python list. And you'll see that it wraps it in this thing called array. And if I wanted to print out simple list instead, you'll see that you just get square brackets instead of saying the word array, like here. So array, and that's a NumPy array, and that's important later on because you can do a lot more things with NumPy arrays than you can with Python lists. But you'll see here that we're using the print method, and then we're using another method called type, and you can see we're printing out the type of simple list, and we're printing out the type of the variable x we just declared. And you can see this is a native list in Python, and the type x is actually a numpy.nd array. Okay, so we created a NumPy array by passing in a variable simple list. Here we're just passing a list directly into the constructor. Either method is identical. You'll see here, creates just like the one above, it created another array of 4 elements, 1, 2, 3, 4. Now, the thing about NumPy arrays is you can actually have multi-dimensional arrays. So you'll see here, I'm creating, in Python, this would be a list, just open and closed here, and then that list would contain 2 sublists, 1, 2, 3, and 4, 5, 6. So that's what we're passing into our NumPy array method, and you'll see what it looks like there. And it's basically the exact same thing you would see in Python as a 2-dimensional list. There you go. And we can look, but with NumPy, you can do cool things like get the size of it. So we get the size of that array, and you'll see that there's 6 elements. So it tells you that there's 6. But it also gives you a shape. So when you run it, the shape attribute, you see that it's a 2 by 3. So 2 rows by 3 columns. And then the in dimensions, you'll see is number of rows dimensions. So how many rows are there? And that gives you just the in dimensions. And you can also look at the data type inside our NumPy multi-dimensional array X. And you can see that it's of type int32. So all these objects inside our 2-dimensional array are all int32 objects. But you can easily convert it to of type float. So floating points have decimal places. And so when I click here, you'll see that it puts the decimal place after it. And what that allows you to do, so if you had 1.3 for instance, you'll see that it gives you the decimal place. But you can force integers to be of type float by passing in the D type and then specifying the type you want it to be. So Control Enter on this line, you'll see that it's of type float 64. 64 is your precision, so it's a 64-bit floating point number. And your int is only 32 bits, so that's how much space in memory it's taking up. You can cast things, so x here we know is of type float 64, but you can convert it to another variable, y in this case, and we're going to convert it to a type int. And that's you using the method asType, and you pass in a string called int, and you'll see that it converted back, so there's no longer the dot after it, so you can see that it's converted those back to integers. But you got to be careful when you do that because you can lose precision. So if we go back up here, and I did that example, we had 1.3. If I do this over here, it drops that 0.3 and just converts the 1.3 here to an integer of 1. So you lose precision, you lose all the decimal places when you convert from a float to an int. So be very careful when you do that. Integer math is much faster, and again, takes up less memory space because it's only 32. So sometimes you want to have integers for different various reasons, but be very careful converting from float 64s to int because you can lose a lot of precision. So now there's a bunch of built-in functions NumPy gives you for creating arrays. There's a method called zeros, and it takes in a shape parameter, which is a 2-item tuple, so it's a 3, 2, which is actually what we learned in previous video as a tuple because it's parentheses. So we have our zeros method, which starts with this green, goes to that green bracket, and then inside of it we're creating this tuple, this 3, 2. That's going to create 3 rows, 2 columns, all zeros for a NumPy array. There you go. 3 rows by 2 columns, all zeros. You can do the same thing for a method called ones, and it'll do the same thing except for create the all one. This I'm going to do 3 by 2. So you get the exact same as above, but using the number 1 instead of 0. Put that back to the 2 by 3. So it's 2 rows by 3 columns. And you notice that when it does it this way, it also does it as a floating point. So you see the decimal place there? So it's actually, if I did the type of it, you'll see that it's an n-dimensional array going to the floating point. Now, look here, we have a thing called I. What that's going to do is going to give you all zeros except for the diagonal of the matrix that you're creating. Is going to have 1s in it, so that's the I matrix in math. So you see there it created a 4 by 4 with all the diagonal elements being the number 1. And this is very important in linear algebra and some other math classes you'll learn about multiplying by the I matrix. And then similar to the I, we have what's called the diagonal. And this is going to do the same thing above. Whatever the dimensions are here, it's going to create a square matrix, putting the values in here along the diagonal. So this will be the first value, this will be the second value, and this will be the third value along the diagonal. And much like we learned the range, so we learned range in previous videos. Let's go ahead and create a new one. We learned about the range in a previous video. NumPy has a range, and it's very similar. So let's go ahead and run and we'll see. It's going to go from 0 to 10, and just like the range, remember we talked about it being inclusive of the first but exclusive of the last. So that's the same thing with a range. So it goes 0 is included, but 10 is not included. It's the one right before 10. And I think, just like in the range method, which is this is not using NumPy, this is using NumPy. So we can also do it by steps of 2 as well. So this is basically the NumPy equivalent of range. So you can also arrange, like I just showed you, in different step sizes. And then NumPy also gives you this method called linear spacing. Now linear spacing is a little different than the arrange in the fact that it's inclusive of both the start and the end values. So they're both going to be included in the list, and then the list is going to be divided linearly by 7 spaces. So you're going to have from 0 to 3, you're going to create 7 objects linearly spaced apart. So every 0.5, 0, 0.5, 1, 1.5, 2, 2.5, and 3. And then if you look at the length, which we saw that method in an earlier video, the length of x is going to tell you how many objects are in the matrix or the object x. So if you run that, you'll see that you created 7. If you want to do 14, that'll make it a lot bigger, but you're going to get 14 objects here. It's going to go from 0 to 3. So your start and end are the same. It's just how many are you breaking up the distance between the two. So that's linear spacing from the start to finish, and the number of objects you want to have in this NumPy array. Now, I told you that NumPy arrays are different than Python lists. So if we try to do math on, so this is a standard Python list, 1, 2, and we're going to try to do math, we're going to multiply it by 3. What that's going to do is going to duplicate this 3 times. Well, that's not what we want. We want this number 3, this scalar, to be multiplied as if this was a matrix. So that should be 3, 6 now instead. And that's exactly what you get when you do it using NumPy. So NumPy knows what your intentions are when you do math on scalars. So what we've created here is the same list, 1, 2, but we've wrapped it in what's called the NumPy array, and we've defined it to the variable x. So if I go here and I go print x, oops, x, you'll see it prints the NumPy 1, 2. Then what I'm going to do is I'm going to multiply x by 3 and then reassign it to x. And what does that give me? That should give me the 3, 6 that I intended. So I multiplied the 1, 2 by a scalar 3. So I'm going to scale each object by 3 inside the NumPy list, or the NumPy array. So what the repeat method does is equivalent of the standard list times the math. So if you want to repeat some list or some object here, it'll repeat this a number of times, and that's but it's going to repeat it a little bit differently. So now it's going to repeat this by 3 and then this 3 times, and that's why you get 1, 1, 1, 2, 2, 2. If you did it by 4, you're going to get 4 1s and then 4 2s. So this method's hardly ever used, but it's more as a method if you want to do something and just repeat something over and over and over again. Now, we can also stack things. So if we have 2 different NumPy arrays, we can put one on top of the other, or we can horizontally stack them. So we're going to use our ones method to create a 2 by 3 multi-dimensional array. And it's going to be all ones. So 2 rows by 3 columns. Then we're going to create 2s by multiplying it by a scalar of 2. So now that's a way to make a list of any arbitrary number that you want to start off with. You just create a ones and then multiply it by your scalar that you want to do. So now I have a 2 row by 3 column, they're all 2s. And I can stack, I can use the NumPy VStack to vertically stack them. And what that's going to do is going to put the 1s on top and then the 2s separately right below it. So now I've got a 4 by 3 with them vertically stacked on top. And then we can also have horizontally stack them. So it'll do the 1s and then 2. So that looks very similar, but it's going to stack them along the horizontal axis. Now the other cool thing about NumPy is with simple lists you can't get measures out of it, but you can with NumPy arrays. So I could do x dot max, and that gives you the max value in this list. So there's 1s and 2s, and it's going to go through the whole list and give you the max. You can do the same thing for min. Now, if you type X and then push Tab, provided you have done this line that I talked all the way back at the beginning, as long as you've done this, you get what's called IntelliSense. So you'll type X dot and then the Tab button, and that should give you everything you can use with your variable X that you have. So there's arg max, arg min, there's different, you can do dot products, there's a bunch of different things you can do. One of them is the mean. You can take the mean of your multidimensional array, and you'll see that it's 1.5. And that's if you summed all these up and then divided by the number of items there are, you would get 1.5 is the average. In this short video, that's really all I wanted to do was go over simple NumPy arrays.